Hi everybody! Today we will talk about beta radiation, an additional form of radioactivity, beta radiation. So, what exactly is that? First of all, there are two forms of beta radiation. Let's start with beta minus radiation. During beta minus decay, an electron is emitted from the nucleus. Wait a second, from the nucleus? But there are no electrons in the nucleus. Yes, that's correct. Usually, there are no electrons in the nucleus, but during beta-minus radiation, a neutron is converted into a proton. During this process, an electron is formed, which is then emitted. The number of nuclides does not change, but the atomic number increases by 1, so the element is changed. The beta-plus decay works the other way around. In the nucleus, a proton is converted into a neutron. Then a positron is emitted. This is the antiparticle to an electron. Except for the sign of the electrical charge and the magnetic moment, all characteristics of the positron are the same as for the electron. So, during beta-plus radiation, the atomic mass also stays the same, but the atomic number decreases. Let's look at the table of nuclides. During beta-minus radiation, the daughter nuclide has a neutron less, so we go one isotope to the left. Additionally, it has a proton more, so we go one isotope up. Let's look at an example. Strontium-90 decays with beta-minus radiation 100% of the time. To find the daughter nuclide, we go one isotope to the left and one isotope up. The beta-minus decay of strontium-90 results in yttrium-90, so the element is changed, but the atomic mass is not. In the case of beta-plus decay, the daughter nuclide has one proton less, so we go one isotope down. Since a neutron is formed, we also go one isotope to the right. Also here, we look at an example, potassium-40. Potassium-40 decays in 89.28% of the cases with beta-minus radiation, and in 10.72% of the cases with something abbreviated with epsilon. However, this is not beta-plus decay, but a process called electron capture. But didn't we want to look at an example for beta-plus radiation? Yes, potassium-40 does decay with beta-plus radiation, but only in 0.001% of the cases, which is why this radiation is not shown here. Beta-plus radiation in general is not happening that often, since the competing process, electron capture, is much more likely to happen. This is why it is difficult to find beta-plus radiation in this table of nuclides. So, let's look for the daughter nuclide. One proton less, therefore one isotope down. Additionally, one neutron more, so one isotope to the right. The beta-plus decay of potassium-40 results in argon-40. Again, the element is changed, but the atomic mass is not. This was a theory, but radioactivity also has a biological effect. Beta radiation can damage the skin and cause burns. If iodine-131, which is decaying with beta radiation, enters the body, it can cause thyroid cancer. This and other unstable iodine isotopes are formed during nuclear fission. To prevent them from entering the thyroid after an accident in a nuclear power plant, potassium iodide pills are handed to people possibly affected by that accident. This was a more detailed look into beta radiation. If you have questions, suggestions, or tips, leave them down in the comments. If you liked the video, like it and subscribe to my channel. See you in the next one.